How do you land 16 tons of high-tech at 180 knots on an ice-covered runway? And how do you make sure all systems are good to go if there should be an alert, regardless of weather at any time year-round? Join us as we go way up north where Saab put their jet fighter systems through cold climate tests. Machines in general are always more or less climate sensitive, regardless of vehicle, making sure it runs smoothly in the scorching sun or blistering cold. Climate tests are vital and carried out for pretty much all kinds of motor-driven vehicles. Jet fighters are no exception, and one could argue that jet fighters in particular pose a bigger challenge due to its many details and advanced systems on board. Also, a jet fighter needs of course to be capable of safeguarding airspaces 24/7, year on end, regardless of weather. And that's why Saab perform cold climate tests, which we will take a closer look at in this first episode of Let's Talk About Tech. This is the place where you get to be co-creators. What do you want to know about defense technology or perhaps just tech in general? Let us know in the comment section below, and in case you're not familiar with Saab, have a look at Saab.com, link also in the description, and by all means click that subscription button because there will be more of this format. Now let's head north. To be more precise, the place we're going to is close to the Arctic Circle, which brings us to the same latitude as the middle of Alaska or the east coast of the Kola Peninsula in Russia, just to give you some reference. And yeah, it does get chilly here. Minus 30 degrees Celsius, which means about minus 22 degrees Fahrenheit, is a fairly common temperature wintertime, but it can occasionally be even colder. Also worth knowing, the winter periods are long. And here in these northern parts of Sweden, Saab is trying out the Gripen fighter system, putting it through cold climate tests. As an Arctic country, Sweden needs to be able to act whenever necessary, regardless of weather conditions. And in contrast to cold climate tests, humidity and heat tests are of course also carried out, but in other parts of the world. And we might just come back for that in a later episode, but for now, let's start freezing. So, let's start with an overall fairly common question. Does ice build up on a jet fighter, and do the same rules apply to commercial jet planes? The answer is both yes and no. To start with, all planes, military as well as commercial ones, don't like ice. To pick up ice means the flying ability will be affected, and if it really comes to it, a plane could potentially crash. For commercial planes, this is solved through built-in systems that heats the cold parts that have picked up ice, and military jet fighters could have this option installed as well. But for most jet fighters, the solution is actually to just go faster, as higher speeds creates friction to such a level that heat is being built up, thawing the plane. Also, a jet fighter such as the Gripen system actually does have a few cards up its sleeve in case there should be an ice problem. De-icing of internal systems is being handled by special heating modes, for instance. And also, worth mentioning early on, is that picking up ice is something that could happen not only during winter time and colder climates, but all the year around, given high altitudes and cloud conditions. So the picking up ice is really not that big of a problem, and actually not really what is being focused on during cold climate tests. But we thought we should bring it up nevertheless for clarity. But there are, of course, other important parts, not least since we're talking about air sovereignty and the ability of being able to take off within minutes in all weathers should there be an alert. Let's take them one by one in logical order. If you have ever started your car in extreme cold, you've probably noticed how the battery really has to work to start the engine. Fuel and oil become thicker and everything is just a pain basically. Pretty much the same goes for a fighter jet. The APU, or Auxiliary Power Unit, is just like on other types of planes, the first thing to check. Can it start after a long night in the cold? Another vital part of the Gripen system is on the inside of the plane, and by that we are referring to software, and more precisely the programs used for monitoring outside factors such as temperature and humidity. A long series of startup and safety checks are performed on this stage to make sure that all sensors are showing reasonable metrics. Furthermore, tests are carried out for trying all valves and hydraulic cylinders. In this case, the main metric is speed and how fast each component moves, depending on the outside temperature. The ground tests are performed in order to confirm that the plane is acting steadily during takeoff and landing on surfaces with really low friction. This is done by starting off with low weight, less external loads and slower speed. Then a series of tests with heavier and heavier load combined with higher and higher speeds follows. Also, in addition to these tests, there are also tests performed on the ground with a degraded system, meaning that you steer by using only the brakes and not the hydraulic steering that the fighter comes with. The testing of the weapon systems is conducted by Saab engineers together with personnel from the Swedish Air Force and FMV, the Swedish Defense Materiel Administration. This calls for more operational exercises where mobile maintenance hangars are used, as well as mounting of weapons are being carried out. So, there you have it, a glimpse of how the Gripen fighter system is put through cold climate testing, a necessary and vital step in order to call itself an Arctic fighter. And if you haven't already, make sure to hit that subscription button and by all means, let us know what you would like us to dig into next. This is a series format where you get to be the co-creator, and if you're not familiar with Saab, check out saab.com and learn more on our business. Let's keep talking, and more precisely, let's talk about tech.